Hi there, we are FTC Team 24751 and welcome back to our FTC 101 series. This is the third video in our FTC Mechanics 101 series and today's topic is manufacturing and 3D printing. Manufacturing is one of the most fundamental and foundational skills in robotics, allowing you to turn raw materials into functional parts. 3D printing is no less important, offering the ability to make complex parts easily. First up is hand manufacturing. This involves using power tools to shape and modify materials manually. Power tools are versatile and relatively easy to use, making them essential for FTC teams. Hand drills are perfect for creating holes in materials like aluminum, plastics, and plywood. Depending on your needs, you have to use the correct drill heads, as the heads used for good metal and those for sandings are different. Electric hand saws, such as circular saws, are great for cutting metals, plastics, and good down to specific size. Safety is crucial when using these tools. Always remember to wear safety goggles and gloves to protect yourself. Secure your materials properly before cutting or drilling. Double check that power tools are turned off before changing attachment or blades. Avoid loose clothing and tie back long hair to prevent accidents. Now, let's discuss a few factors to consider when using these tools. Cutting wood or metal can create friction, leading to burns or even fires. To prevent this, avoid applying too much pressure and cut bit by bit while also paying attention to the good's condition. Drill bits come in various shapes for specific materials. For example, twist drills are best for metal, while spade bits are better for wood. Be mindful of tools recoil, especially with drills and saws, as it could be a serious danger hazard.
Next, let's move on to machining. Machining is also quite common in FTC and is used to make custom parts in your CAD. However, not all teams have access to a bandsaw, drill presses, or CNC machines, so it is more common for teams to order CNC parts. The custom parts that normally need to be CNC'd are plates such as drivetrain plates or intake and outtake boxes. Finally, let's talk about 3D printing. This technology is a game changer in FTC, allowing teams to create custom parts with complex designs. There are several filament options to consider. PLA is affordable and easy to print but less durable. ABS is stronger than PLA and somewhat heat resistant. PETG combines the best of PLA and ABS with good strength and flexibility, and TPU is a flexible filament ideal for shock absorbing parts and parts such as intake rollers. Now, let's walk through the 3D printing process. Start by designing your part in CAD using softwares like SolidWorks or Onshape. Export your CAD file as an STL and open it in a slicer software like Ultimaker Cura. Adjust your settings to fit your part's requirements. Infill determines the part's internal structure. For most parts, 20 to 40% infill is sufficient. Wall thickness affects the outer strength of your part, and thicker walls make the part more durable. Adjust printing speed based on the material. Slower speeds generally result in higher quality, and supports are needed for overhangs or complex shapes. Once your settings are adjusted, upload the G-code to your printer and start the print. Here are some tips to help you succeed in 3D printing. Make sure your print bed is level to ensure good adhesion. Keep your filaments dry to avoid clogs and poor print quality. You can use a glue stick or even a light coat of hairspray to help with bed adhesion. Test your printer's capabilities, including its tolerance and speed, before using it extensively. Each 3D printer is different, so you need to tune accordingly. And remember, practice makes perfect, so keep experimenting and refining your skills. There are no shortcuts in robotics. Thanks for watching and good luck on the competition field. See you next time and stay tuned for the next video.